Hi, so I am a robotics engineer, and today I'm going to talk about rapid prototyping and how I learned that it was more than just 3D printing. Rather, rapid prototyping, like this talk, is about speed. Next slide. So the answer to the title question depends on who you are. This is a bioinfographic that I use to kind of map out my skill set and decide what I could do myself and what I would like to outsource. So knowing yourself is going to be very useful. So this is a 3D printed gimbal that is printed using a technology called print in place, where you don't have to do any assembly. All of this requires no external mechanical fasteners, and it has very high precision, like this laser cut print here, which also has high precision but can be done much faster and at lower cost. And you can still get some 3D features using layering, as you see on the right, or etching, as you have here on the left. So this was what I chose to use for most of my project. So this was an early drone prototype that I made called a dual quad rotor, where the concept has a small drone on top that is acting like a tugboat to move the bigger drone on the bottom, and the two act cooperatively to sense and avoid obstacles. This is a spec sheet for the materials that I used for this, and what I wanted to do is first figure out what I needed. So most of the drone was carbon fiber, which was very expensive, but for the parts that didn't need to be structurally strong, I used Garolite, a much cheaper composite. So this is a map of my system architecture. Like any smart product, it has sensors, actuators, and a controller, which uses feedback from the sensors to tell the actuators what to do. So this is a good tool for understanding how your different parts are going to connect together. This is a close-up of the computer architecture. This is another tool that's a block diagram that helps you understand what different protocols and communications channels you're going to need to actually hook up all of your embedded systems. And when you're ready to purchase those embedded systems, you want to find vendors that are very close to you. Adafruit here is local to New York. They also have a learning system which will help you get started very rapidly with a lot of example code and tutorials. SparkFun is very similar. So this is the embedded system that map represents, and what I did here was color-code the wires. As you can see, there's hundreds of them, which saved me a lot of time when I had to debug issues on this. So I highly recommend being organized and adding some method to your madness. Similarly, this is a block diagram of the power distribution system where I mapped out all the requirements. My motors were going to need high voltage, my servos medium voltage, and my lasers and LEDs were going to need low voltage. So this saved me time having to rebuild. This is a close-up of the power architecture where I linked all of the 4 batteries together so that I could recharge them much faster, which saved me a lot of time in terms of my test flights. So some choices in hardware will give you easier tasks in all your other operations. These are the hardware vendors that I use. McMaster-Carr is very helpful, helping you not just buy parts, but describing what they actually do. I highly recommend them. This is a close-up of the gimbal that I designed on a earlier prototype. And here I decided, instead of trying to print in place that joint there, to buy that off the shelf, use fast 2D printing, and use those standoffs for depth. And so eventually I came to this much simpler design, which is a quad tilt rotor, which still allows me to do the original concept of separating attitude control from position control for obstacle avoidance and detection, but with much fewer parts. As you can see, those propellers can tilt there, and that's what gives me that thrust vectoring, which gives that kind of novel maneuvering. This is the first of its kind in the world. Next slide. Oops. Right, and this is a close-up of that tilt rotor mechanism. In order to save time designing this, I used an off-the-shelf tilt mount there with a custom laser cut part there to interface with this prop cage. And instead of making a 3D part there, I used an angled piece of plastic and then, again, used 2D manufacturing, subtractive manufacturing, with a laser cutter to make that hinge there to reduce vibration. And this is kind of like an elevator shaft test rig that I made to kind of train my drone to fly before it knew how to fly. So this saved me time in having to rebuild the drone when it would inevitably crash. So basically, this is a sideways picture, but it could only go up and down in that shaft. And this is a high-level programming language I use to avoid having to do a lot of low-level programming. Essentially, this code you see here sits in one of those blocks. And this line here that says code gen allows me to automatically generate code for the Arduino, so I didn't have to program in that very tedious to debug environment. So my advice for rapid prototyping is try to optimize for speed at all of your different intervals. That'll allow you to iterate faster and get to success quicker. Thanks.